Chapter 10, Section 4, we're talking about more matrices. We're going to focus on mostly determinants and inverses of matrices today, along with a little bit of area work here. So go ahead and write this off to the side of your example 1. Okay, we are going to talk about the determinant of a matrix. Okay, the determinant is kind of the basis of finding the inverse and finding the area and finding other things. Okay, so in order to find the inverse especially, we need to know what the determinant is. So I'm going to give you a formula here that I want you to write down. And I'm basing it off of this matrix for now, for a formula. Okay, so we take the determinant of matrix M equals, and then to find the determinant, it's going to be A times D minus B times C. Okay, looking at that formula right there, what are the relationships in the matrix from that formula? They're across from each other, right? We take A times D, and then we subtract off B times C. So it's kind of cross-multiplying in there, okay? So that is the formula for finding the determinant, okay? Like I said, the determinant is going to help us find the inverse later on, and that's the most important part, okay? So finding the determinant, you just follow this formula right here. What's happening between A and D and B and C? They're being multiplied together. Yep, and I had a good question last period. They said, why is it subtraction? That's just what the formula says, okay? That part's always going to be subtraction. Cool? All right, so we're going to look at your example 1. Ignore the directions for now, okay? I want us to find the determinant of this matrix, okay? So we say the determinant of M equals, well, remember we kind of cross here. We take AD times BC, and that's always going to be in the order of A, B, C, and D. Okay, so what is my A and D? Yep, so I take 1 times 3 minus B times C, which is 5 times 1.
You have to have it 5 and 1 or 1 and 5?
Are you talking about how I write it here?
Yeah.
It doesn't matter the order. Yep, good question. So from here, we just evaluate what's 1 times 3. 3 minus 5 times 1. 5. And then lastly, subtract 3 minus 5. Negative 2. And it is okay to have negative determinants, just if you're finding the determinant. Okay? All right, now we're going to talk about the inverse. Go ahead and write this again off to the side of where you wrote the determinant stuff. You can write it underneath there. Okay, so I'm still working with this same general matrix here, that A, B, C, D. Okay, when we're finding inverses, now we have talked about inverses a lot. Okay, we haven't talked about them with matrices, but what does inverse mean to you? Inverse is like the opposite, right? It's what gets you back to the original. Okay, so the inverse still means the same thing for a matrix. It's the opposite matrix to get us back. Okay, so for the inverse, do you remember what signifies an inverse? It's the m to the negative 1. That stands for inverse. Go ahead and label that. M to the negative 1, that's our inverse notation. Okay, so the inverse of a matrix, again, I'm going to give you another formula here. This follows, we take 1 over the determinant of matrix M times matrix D, negative B, negative C, and A. So I'm going to ask you this. What's happening between this fraction and this matrix? What operation? Yep, they're right next to each other, so it's going to be multiplication. Let's just talk about what we see here. Look at this fraction. What do you notice? It's the determinant, right? We just talked about it, right? So to find the inverse, we use the determinant, but it's 1 over that determinant, okay? Let's focus on this matrix here. Is that the same as the beginning? No. Let's talk about what happened. What are some things that happened?
We have negatives in there.
Right. Think about where they were placed in the beginning. A was here, and now it's here. What? Right. What happened? Right. A and D, they just switched spots. Okay. A and D flipped. What happened to B and C? Did they switch spots? Right. Did they switch spots at all? No. What happened? They switched signs. Now I'm going to ask you this. If I said, I'm going to say the original B was, let's just do a matrix example. Put this next to it. So if I give you, for example, 3, -2, 5, and -4. Okay. Let's talk about what that would turn into for this part of our equation. Okay. So what happens to our A and D here? They switch places. Yep. And then what happens to our B and C? Sign switch. Now, this is a -2. Does it stay -2? No, it switches to +2. Good. And then what happens to this 5? Turns to a -5. Awesome. Even if it starts out as negative, that B and C is just going to switch their signs. Okay? So this is back to your example 1 that we did. Help me out. What did we say the determinant was? We got the determinant of -2. Okay, so now we are going to follow, and I'll write that formula again. We are going to follow the inverse formula, which was 1 over the determinant of M times D, -B, -C, and A. That's the formula we're going to follow. Okay, so let's plug in what we know here. What is our determinant? So we have 1 over -2 times, now, do we take our original matrix and multiply? No, what are we doing? We got to switch it up, right? Follow this formula here. We got to switch it up in this form. So what happens to 1 and 3? Yep, sorry, that's 1 and 3. They switch places. So this turns into 3, this turns into 1. And then what happens to 5 and 1? They turn negative. Yep, so this turns -5, this turns -1. So someone already noticed. Now we need to multiply here because what's happening? Multiplication. What do we do with a scalar? This is like our scalar. How do we multiply? It goes to every single term. Yep, so 1/2 goes to 3. Sorry, -1/2. -1/2 goes to -5, and so on. Let's do a little review of multiplying fractions. Okay, so if I have -1/2, I'm going to do the 3 first, times 3. How can I multiply this? What can I treat that 3 as? Over 1, yep. And then what happens is we just multiply straight across. No, it's going to be negative. What's 1 times 3? 3, and then 2 times 1 is 2. So you just multiply straight across. What's going to happen is that denominator of the determinant is just going to end up on the bottom of all of these. That's what's going to end up happening. Okay, watch out for your negatives. So if I do that, we get -3 over 2, +5 over 2. Oh, I said 2, I wrote 5. +5 over 2. And then we get +1/2, and then we get a -1/2. You can leave your answers as improper fractions. What I mean by that, this one and this one, you can just leave them that way. However, if I get a fraction that looks like 4 over 6, can I leave it like that? No, what do we want to do with that? We want to simplify and reduce. Let's do a quick review. How would I reduce this? I would divide both by 2 to get 2/3. Yep, so if you can reduce fractions, always reduce those. So we just found that is our inverse matrix of the original. In order to find the inverse, what did we have to know first? I'm going to back up. In order to use this formula here, what did we have to know? We had to know the determinant. Yep, we had to know what that thing was before we could find the inverse. All right, I'm on example 2A. The directions say it wants to find the inverse of matrix P. Now, in order to find the inverse, what do I have to know first? I have to find the determinant first. So, the determinant of P, how do I find that? So I take -4 times 3 minus 2 times -6. And then we keep going. -4 times 3, -12. Minus 2 times -6. -12. What happens to those two negatives? Become positive. -12 plus 12. 0. Now that I have the determinant, can I find the inverse? Yes. So finding inverse of P, we take 1 over what?
0.
The determinant 0 times. Now what happens when we set this matrix up? A and D switch, so this becomes 3, -4. What happens to B and C? -2 and +6. Good. Now, whenever you can simplify this fraction over here, simplify. Okay, type 1 divided by 0 on your calculator. Error, right? Let's say I have all of you in a group. There's 8 of you. And I say, okay, divide yourselves by 0. What would you do? Why? Does that make any sense? If I say, okay, stand up and divide yourselves by 0. Does that make any sense? No. This right here is a no. You cannot divide by 0. So, if this gives you an error, what do you think your answer is? No solution. There is no inverse for this matrix. Okay. So, as a little note up here, write the determinant of a matrix M cannot equal 0. If it equals 0, there's no inverse. And it's okay for matrices to not have an inverse. So, moving on to example 2b. Same thing, we're finding the inverse. What do I need to know to find the inverse first? The determinant. So, determinant of Q equals, tell me what I need to write here. 7 times 1 minus 3 times 2. Continue on. 7 times 1. 7. 3 times 2. 6. 7 minus 6. 1. Can I have a determinant of 1? Yes. What is the only thing I can't have a determinant of? 0. Good. So we're good to go here. Now we're going to find the inverse of Q. Tell me what I need to write. It's 1 over our determinant 1. Well, we can just leave it like that for now. What happens to my matrix? Yep, tell me what I need to write here. What switches? 1 and 7 swap. -3, -2. Now, what I said, always simplify this when you can. What's 1 divided by 1? Just 1, right? Okay, what can I do from here? What did we normally do when we had a scalar out front? What did we do with this number? We distributed it to everything. Well, if I multiply 1 by everything, does anything happen to it? No, it's just itself, right? So, yep, it's just this matrix. This is the inverse of our beginning matrix. Yep. So if you ever multiply by 1, remember that doesn't change the matrix in the problem. Now we're going to talk about finding the area of a triangle determined by 2 vectors. Now, yesterday we talked about vectors. Remember, whenever I say vector, that just means this form. Okay? Yesterday we talked about how we can write vectors into matrix form. You remember that? Okay, so if I want to write this x1, y1 as a matrix, remember that just turned into x1 on top, y1 on bottom. So, if I wrote this one as a matrix, what would it be? X2 over Y2. Yep. Now, can I, and I'm asking you this, can I put these two into one matrix? How could I do that? How can I write these two into one matrix? Exactly, you're pushing your hands together, right? That's exactly what's going to happen. It's going to turn into x1, y1, and x2, y2. Okay. So, biggest thing, when you have vectors, remember you can turn them into matrices. Okay. Okay. So, when we get the vectors into this matrix form, we can find the area of the triangle that these vectors form. Okay, and again, they're talking about the triangle on the coordinate plane like we saw yesterday. Okay, they're talking about finding the area of that. I won't give you the picture, okay? I will just give you the two vectors, okay? So, here's one more formula for today. It's the area. So, area equals 1/2 times the absolute value of the determinant m, with m being that matrix. Okay. Oh, I miswrote something. Make sure you fix that on yours too. Okay. I kind of already said it, but what do these two bars mean? Absolute value, right? So remember, for example, if I gave you the absolute value of -6, what's the absolute value of -6? 6. Does anyone know the actual definition of absolute value? Other than that it changes negative to positive. Okay. I'm going to ask you this. Absolute value of 5. It's always going to be positive. Okay? Always going to be positive. Okay? So, absolute value is however far away that number is from 0. So, if I'm on a number line and I have -6, how far away is -6 from 0? 6, right? Can distance ever go negative? Like in real life. Can I ever go negative distance? No. You can lose time, but you can never go negative distance. No such thing. Okay? So, for area, is there ever a such thing as negative area? No. That would just be an area that's non-existent. Okay? So, the reason for that absolute value is to make sure that our area is always going to be positive. Okay? So, let's take a look at your example 4. So, first thing I want to do, it wants us to find the area. But can I find the area when the vectors look like this? No. What should I do first? Put them in a matrix. Yep. So this turns into -2, 10, and -1, -5. I turn my two vectors into a matrix. Okay. Now from here, I'm going to write that formula again. It says area equals 1/2 times the absolute value of determinant M. In order to find the area, what do I need to find first? I need to find the determinant. We know how to do that, right? So, determinant of M, tell me what I need to do. -2 times -5, yep. Minus -1 times +10. Yep, nope, you're good. What's -2 times -5? +10, good. And then -1 times 10. -10. What happens to those two negatives in there? They turn to positive. So 10 plus 10, 20. Is that the answer for my area? No. That's my determinant. So now, since we know what that is, we can go ahead and plug in to our formula there. So we have area, I could just put A, equals 1/2 times the absolute value of our determinant, which is 20. What is the absolute value of 20? Yep, stays 20. Now, just take 1/2 times 20. What's half of 20? 10. So our area of that triangle from the vectors is 10. I just got asked, how do you know what the absolute value is? So, absolute value, I'm going to use two examples. So if I have the absolute value, I'm going to say of 13. What this is asking is it's saying how many units is 13 away from 0? That would be 13, right?
So will it always be something?
Yes. So if I plug in, I'm going to say -13. Well, how many units away is -13 from 0? 13. Yep. So another review. What's the absolute value of 17? 17. Absolute value of -17. 17.
I thought it changed.
Signs. Is that what you thought?
Yeah.
Okay. Yep. Just remember, nope, you're good. That negative inside the absolute value is always going to go away. Yep. All right. Go ahead and do example 4B. All right. It wants us to find the area. In order to find the area given vectors, what do we have to do first to those vectors? In order to find determinant, we have to do what first? Matrix first. Yep. So this matrix turns into what? 8, 7, 4, -3. Good. So remember, this was your first vector. This was your second vector. So now, what do we need to find in order to find the area? Determinant. Yep. So determinant of M. How do I find that? Yep. You can think cross multiply. So I take 8 times -3 minus 7 times 4. What's 8 times negative 3? Negative 24. And then 7 times 4. Yep. So what is, if I subtract those, what's negative 24 minus 28? Careful. They're both negative. I'm going to get negative 52. Yep. Now that I know the determinant, can I find the area? Yep. So area equals 1/2 times the absolute value of what? Negative 52. Yep. Right. The absolute value of negative 52 is just 52. So now take 1/2 times 52, which is 26. So our area is 26.